This video covers Descartes' rule of signs. This rule helps us to determine the possible number of positive and negative real zeros of a polynomial function f of x. To use this, we need to make sure that our terms are arranged in order of decreasing powers of x. We also need that the constant term or the number is different from 0. So we need a non-zero constant. And the way we determine the possible number of positive and negative real zeros of f of x is by looking at variations of sign in f of x and in f of negative x. And if you need to pause the video to kind of read through this a little more carefully, go ahead. But I'm going to jump down and start on number 1 here. So we are interested in the solutions to this equation here. And Descartes' rule of signs, well, I guess it's not going to really help us to find the exact solutions, but it is going to help us to determine how many possible positive real zeros or solutions we're going to have, how many possible negative real solutions, and then we'll use that information to help us to determine the possible number of complex solutions. So we're wondering, what do the solutions of this equation look like? So you start and you look at the signs of the terms in f of x. The first term is a positive 7x cubed. So we start with a positive term. Our second term is a negative 4x squared, negative, followed by a negative 3x, followed by a positive 6. Now we need to figure out the number of variations of sign in this function, or in this equation here. And I've used, plus signs and minus signs to help us to do that. So the first term was positive, the second one was negative. That is one variation of sign. Then you have a negative term followed by another negative term. No sign change there. But then we go from negative to positive here at the end. That would be a second variation of sign. The number of variations of sign in f of x tells you how many possible positive real zeros that function has. Okay, so possible, positive, I should say number of. So number of possible positive real zeros would be 2, or, so it's that number, or it's less than that number by an even integer. So our other possibility would be none, and I'm getting that by taking the number I got, which was 2, and subtracting even integers. 2 minus 2 is 0. Now, technically I should subtract then 4 and 6 and 8, subtract even integers. But I know if I subtract 4 or 6 or 8 from 2, I'm going to get a negative number. And it's not possible to have a negative number of real zeros. So I take 2 or 0, or 2 or 2 minus 2, which is 0. So there are 2 or 0 positive real zeros, or positive real solutions to this equation here. Okay, next what I need to do is I need to find f of negative x. So I'm going to take negative x, and I'm going to plug it in for every x in the equation. So f of negative x is equal to negative 7x cubed minus 4x squared. Okay, now let me explain why this became a negative 7x cubed, but this one stayed minus 4x squared. By order of operations, we need to square or evaluate the exponent, so in this case cube. but we need to evaluate exponents first. So when you square a negative x, and you take negative x times negative x, you get a positive x squared. And we take that positive x squared and multiply times a negative 4, it is going to be a negative 4x squared. And when you cube a negative x, it is a negative x cubed, which is why it changed to negative 7x cubed. So be real careful with that. Plus 3x plus 6. Okay, I'm going to do the same thing here. I'm going to write out the signs of the terms of f of negative x. First, I have a negative 7, then I have a negative 4, then I have a positive 3, and then I have a positive 6. Okay, so my signs are negative, negative, positive, positive. Once again, I'm interested in the number of sign, or the number of variations of sign in f of negative x. There's only one. A negative to a negative, same sign. Negative to positive, we've got to change there. So then positive to positive, same sign there. So there's only one variation of sign. This tells us the number of possible negative real solutions. And that is 1, or we have to decrease that number by an even integer. But when you take 1 minus 2, we already get a negative, which is not possible. So it would have to just be 1. Okay, now we're also going to determine the number of possible complex solutions of the equation. To explain that, I'm going to make a chart to kind of help us to do that. All right, so I'm going to make a chart, and over here, I'm going to write positive, negative, and then C for complex. Here's scenario 1, here's scenario 2. So we can have either 2 or 0 positive real solutions. So one scenario is maybe there are 2 positives, and the other scenario is maybe there are no positives. Negative has to be 1. There's no other possibility. So we actually know for sure that there's 1 negative real solution. Now, to figure out the possible number of complex, we have to look at the degree of the function. The degree is 3. So I know that the total here needs to be 3. We've seen that the number of zeros or solutions is equal to the degree. Now, sometimes we have double roots, which is kind of a whole nother concept here, or a whole nother topic, I guess, not concept. But I do know that the total has to be 3. Total is going to be the same as the degree, as long as you count, or as long as you take multiplicity into consideration. So looking at scenario 1, 2 positive real, 1 negative real, that would mean there'd have to be no complex, because I need these numbers to add to 3. So if I've got 2 positive, 1 negative, that would mean I'd have to have no complex. But if I don't have any positive and I have 1 negative, then there would have to be 2 complex. So for number of possible complex solutions, we have a possibility of 0 or 2, depending on which of these scenarios it is. Now, I did use technology to see which scenario it was. It ended up being scenario 2. This is not something you'd have to do. You're just going to list the number of possible positive, real, negative, real, and complex solutions. But if you were to use technology, I used the Wolfram Alpha website and plugged in the equation. I found out that there's 1 negative and there are 2 complex solutions to this equation. This equation is like near impossible for us to actually solve. We're just listing possible positive, negative, and complex solutions. Okay, let's look at another one. So I'm going to start and I'm going to look at the signs of the terms in f of x. Got a positive 3x to the fifth, a negative 4x to the fourth, a positive 2x squared, negative 4x, negative 1. Now notice that I'm missing a term. I do not have an x cubed term, but the rule still works as long as the number term is non-zero. So we can have a missing term, and that's not a problem. I'm looking for the number of sign variations. I've got positive to negative, that's 1. I've got negative to positive, that's 2. Positive to negative, that's 3. Negative to negative, nope, no sign change there. So because I have 3 variations of sign, then the number of possible positive real zeros would be 3 or 1. We're going to take this number and we're going to subtract even integers. Our first even integer would be 2. 3 minus 2 is 1. Now we could subtract 4 and 6 and 8 and 10, but that would give us negative numbers. And that wouldn't make any sense. So that means there are either 3 positive or 1 positive real solution. Okay, now we look at f of negative x. So we're going to substitute negative x, 4x, into the equation. So f of negative x is equal to negative 3x to the fifth, because negative x to the fifth power is negative, minus 4x to the fourth. This is because when you raise negative x to the fourth power, it's a positive. And then when you multiply by negative 4, it's negative. Plus 2x squared. Okay, same reasoning here. When you square negative x, it's positive. Plus 4x minus 1. And I'm going to do the same thing where I look at positive, negative, negative, positive, all that good stuff. So negative 3, negative 4, positive 2, positive 4, negative 1. Okay, so I'm looking at negative 3, negative 4, positive 2, positive 4, negative 1. And I'm looking at the number of variations of sign. Negative to negative is not a change. Negative to positive is a change. Positive to positive is no change, but positive to negative is a change. So I have 2 variations of sign in f of negative x. This tells us the number of possible negative real zeros or solutions. They're either going to be 2 or 0. Okay, I get the 0 by taking 2 minus 2. Now I'm going to make a chart. That's going to help me to determine the number of possible complex zeros. So positive, negative, complex. This time I will have 4 scenarios. I'll explain where I'm getting 4 from. So here's scenario 1, 2, 3, and 4. So we have the possibility of 3 positive or 1 positive. But each of those possibilities needs to be paired with each of the possibilities of the negative. So you might have 3 positive with 2 negative, or 1 positive with 2 negative, or 3 positive with 0 negative, or 1 positive with 0 negative. So I've got to pair the 3 with the 2, and the 1 with the 2, but I've got to pair the 3 with the 0 and the 1 with the 0. So that's how we're getting 4 possible scenarios. Now remember that our total number of zeros needs to add to the degree of the polynomial function, which is the largest exponent, which in this case is 5. 3 plus 2 plus 0 is 5. 1 plus 2 plus 2 is 5. 3 plus 0 plus 2 is 5. 1 plus 0 plus 4 is 5. So if you look at this bottom row, it tells you the number of possible complex zeros. There could be 0, 2, or 4 complex zeros. All right, so number of possible positive real, 3 or 1. Number of possible negative real, 2 or 0. Number of possible complex, 0, 2, or 4. Again, this rule doesn't tell us what the actual solutions are. It just gives us the possibility for how many of each type we're going to have. Okay, let's do one more. Last one for this video. First, I'm going to start with f of x. You've got a positive 2, a negative 5, a positive 8, and a positive 9. The number of variations of sign will tell me how many possible positive real solutions I have. Positive to negative is 1 change. Negative to positive is 2 changes. Positive to positive, that's not a change, so there's 2. So our number of possible positive real, okay, so number of positive real solutions would be 2 or 0. I'm always going to decrease the number by an even integer, or by all even integers that you can. So I'm going to subtract 2. I can't subtract 4, I can't subtract 6 or 8 or 10 because I get negative numbers, which wouldn't make sense. So 2 or 0. Like I said, the 0 is coming from taking 2 minus 2. Okay, now I'm going to find f of negative x. I'm going to plug negative x in for each x. And by order of operations, I do need to evaluate the exponents first. So that first term is going to be a positive 2x to the 4th, because when I raise a negative x to the 4th power, it's a positive, plus 5x cubed. That one is a plus because when you cube negative x, it's a negative. A negative times a negative is positive, minus 8x plus 9. And then now I'm going to do the same thing for f of negative x. I'm going to look at the sign. So it starts with a positive 2, then I've got a positive 5, negative 8, positive 9. I'm going to look for the number of variations of sign. Positive to positive, no change. Positive to negative is a change. Negative to positive is a change. So it looks like we have 2 again. So the number of negative real solutions would be either 2 or 0. And then to figure out the number of possible complex solutions, I like making a table. I think it's helpful. So we've got positive, negative, complex. I know that I need a total of 4 zeros because the degree of the polynomial function is 4. I'm going to pair 2 with 2. I'm going to pair 0 with 2. I'm going to pair 2 with 0. And I'm going to pair 0 with 0. So notice I'm taking this number and pairing it with 2. I'm also taking the 0 and pairing it with 2. Then I'm taking 2 and pairing it with 0, and 0 pairing it with 0. So we have 4 different possible scenarios here. If there are 2 positive real solutions and 2 negative real solutions, there will be no complex solutions. If there are 0 positive and 2 negative, there'd have to be 2 complex. I'm wanting each of these columns to add to 4. So just as we had in the last problem, the number of possible complex solutions would be 0, 2, or 4. Just look at that last row. All right, so once again, this rule is kind of neat. Tells you the possible numbers of positive real and negative real solutions, from which then we can find the number of possible complex solutions. However, it doesn't tell us what those solutions are. It just gives us the possibilities. Thanks for watching.